You walk into a cafe on your morning commute and tap your smartphone against the payment terminal to grab a coffee. It feels like a single, seamless action. By the time you pay, your device has communicated across 5 distinct networks: cellular, Bluetooth, Wi-Fi, NFC, and GPS. This bottom note clarifies your phone relies on dedicated physical radios built into its hardware for every communication method, which raises a pretty obvious question. Why pack a device full of different hardware radios instead of building one universal network that handles everything? The answer comes down to physics. Maintaining a wireless connection requires a strict zero-sum balancing act between 3 things: the power it consumes from your battery, the geographic distance the signal covers, and the financial cost to keep it running. The moment you walk out your front door and lose your home internet, your phone falls back on your carrier's cellular network to keep your data flowing. Cellular networks offer city-wide range, but tapping into that infrastructure comes with restrictions. Bandwidth is limited and packaged into data plans. Notice this final bullet point. If you move out of 4G range, the phone automatically drops to 3G, keeping you connected. At the exact same time, a separate GPS radio inside the phone is passively catching pings from satellites orbiting the Earth to calculate your exact geographic location for the map on your screen. These wide net radios are vital for keeping you online while moving across a city, but their heavy power draw and expensive data usage make them the wrong tool for close-range tasks. When you put in your wireless earbuds on the train, you transition to a completely different scale of connectivity, the personal bubble. This slide breaks down why Bluetooth is the right tool for this. It completely bypasses cellular towers and Wi-Fi routers. Because it operates entirely without that infrastructure, it consumes very little power, but you are strictly limited to a range of about 32 feet. To connect, devices undergo a pairing process. As outlined under Discoverable Mode here, your earbuds broadcast their name, class, and services. Moving down the slide, the receiving device often requires a PIN. Once entered, the phone stores it to automatically trust the device later. Contrast that 32-foot bubble with the NFC, near-field communication, you use to pay at the cafe. Its radio range is so small it requires near-physical contact with the payment terminal to complete the circuit. Both Bluetooth and NFC deliberately sacrifice long-distance coverage. In exchange, they deliver extremely low power consumption and high physical security for immediate, localized interactions. Once you sit down at the cafe and open your laptop, you actively configure your devices to join a local Wi-Fi network. As the presentation notes at the top, Wi-Fi doesn't count against your cellular data plan and uses significantly less power, conserving battery life. But shared public networks carry risks. As the security section highlights, always use WPA2 encryption and activate a VPN to shield data. To find the cafe's specific network, your phone looks for an SSID. As this text defines it, the service set identifier is simply the technical name of the Wi-Fi network. Some routers broadcast it openly, while others choose to hide it. If the cafe hides its SSID for privacy, you have to set up the connection yourself. According to this slide, you must manually provide the device with 3 specific pieces of information: the exact SSID, the security type, and the passphrase. If the cafe's internet is down, you have a backup plan. As detailed here, you can use your phone as a tethering device, or PAM, phone as modem. This creates a personal hotspot, sharing your phone's cellular connection over Wi-Fi to your laptop. Wi-Fi serves as the crucial bridge in this ecosystem. It gives you the high data bandwidth of a macro cellular network combined with the lower battery drain of a localized Bluetooth connection, creating the ideal middle ground for stationary work. Your smartphone acts as an automated network manager, constantly juggling this invisible relay race of physical radios to keep you online as you move through the world. You can assist that internal manager by manually switching over to trusted Wi-Fi networks whenever you are stationary. You'll stop burning through your cellular data cap and drastically extend your battery life. And whenever you rely on shared public infrastructure for that Wi-Fi, keep your data locked down with a VPN. By understanding how these distinct protocols balance power, distance, and cost, you can optimize your device's performance, preserve your battery, and keep your personal data secure.